was the output, and in the case of the regression tree, the tree structure will be the output. So this is the given data. We have the data in hand. Based on this, we are going to develop that regression tree. So we have data for 14 days, say for example. So for each of the 14 days, we know that, say for example, for day 1, the outlook was sunny and temperature was hot and humidity was high and wind was weak. So in that case, some 25 players turned up and so on. So we have this data as input. So with this data, how are we going to build the regression tree? So here this technique is going to use the standard deviation as the formula to develop the entire regression tree. So first we have to start by calculating the standard deviation of the complete data set. So what is the standard deviation for this complete data set? So in order to calculate the standard deviation of the complete data set, this is the formula. So here it is given that, so we are worried about the number of golf players, which is the output. So we have the output values like 25, 30, 46, and so on up to 30. That is the values that is displayed in the last column. Are you following me? Are you able to hear me?
Yes, sir.
Yeah, okay, I'm continuing. So these are the values that are given in the table. So in order to calculate the standard deviation, we need the average of these values. So average of these values is equal to sum divided by the total number. That gives the average value. So here I'm going to give you some overall, like I'm going to tell that this is the average and this is how it is calculated. I'm not going to do this 25 plus 30 plus 46 and so on divided by 14. That you can do it by yourself, and it is there in the PPT. So what I'm going to do is that I'm going to mention that the average is going to be calculated. I hope you'll be able to follow me, right? So first the average value has to be calculated. So 25 plus 30 plus 46 up to 40 divided by 14 will give the average value for this entire data, the last column, the output column. So based on this average value, the mu, the standard deviation value will be calculated. So we take each and every value, say 25, 30, 46, and so on. So each value, we calculate the difference between each value and the average value. We calculate the difference and then we square it, and we sum it up with the squared difference of the other values also. Next we take 30, we take the difference between 30 and the average and then square it, and then we take 46, we take the difference between 46 and the average 39.78, and then we square that, and so on we continue, and we sum up all the squared difference between the average, and finally we take the square root. So as per the formula, we get the standard deviation of this data as 9.32. So if you need any clarification at any point of time, you can stop me. This is very simple, basic mathematical, like arithmetical operation. So I'm not going to much elaborate. I hope you are able to follow from this formula, all these calculations. So standard deviation for this entire data set is calculated to be 9.32. Now we have to calculate the standard deviation of the individual attributes. So why do we need to calculate? You will be able to understand when we start constructing the tree. See, basically what we are going to do is we are going to construct a tree like this. So I'll directly show you the output and I'll come from the bottom up, so you'll be able to understand. So what we are trying to do is we are going to build a tree like this. So in the input data, I hope you can recollect, there are some 4 input attributes like outlook, temperature, and wind, and one more. There are 4 input attributes based on which the number of players are predicted. So whenever we are going to draw this decision tree, at each level there will be some attribute based on which you are going to take the decision. So uh, we are going to develop this decision tree by identifying what attribute will be the splitting attribute in each point of the decision tree. For example, this is the root of the decision tree. So from our calculation, whatever we are going to do based on the standard deviation, we will be deriving that outlook should be the root of the tree. So we take the outlook as the root of the tree. So we start. So whenever we are given with a new record, say for example, outlook equal to sunny, and then temperature equal to hot, and wind equal to weak. So how many players will be actually coming for the game today? So whenever we are given such values, so first, what is the value against which we are going to test the decision? So that order is determined by all our calculation, and that is what we are putting in the form of a tree. So the first question will come based on outlook. So what is the outlook value for the required input? So if the outlook is sunny, then we follow this branch. If the outlook is overcast, we follow this branch, and the outlook is rainy, then we follow this branch. Say what if the outlook equal to sunny and the temperature equal to high. So when outlook equal to sunny, we come to here. Then after this, based on the temperature, we branch out into these three branches, like temperature equal to cool, or temperature equal to hot, or temperature equal to mild. So here temperature is equal to high. So we take this temperature equal to hot branch, and we can say that 27.5 players will be coming if outlook equal to sunny and temperature equal to hot. And on the other side of the outlook sun outlook branch, you can see that in the rainy branch, you can see that it is wind. And on the right side, you can see wind. Value. So it is a dynamical. There is nothing to decision. If you say that outlook equal our calculation. I hope you are able to understand what we are trying to build. Now, so coming back to the calculations, there's going to be lots of numericals. So what we are going to do is we have to each attribute, like outlook, it will give us more information in the root level. So we will take each attribute one at a time. So first we will take how many overcast and rain. So these are the three types of outlook. Calculation for outlook, sunny, overcast, and rain, and then we have to do the calculation for temperature equal to mild and temperature equal to cool, and then we have to do a calculation for high and normal. Together we are going to do 10 calculations. So at the end of these 10 calculations, or 10 values, we will be able to do entry. So that 10 calculations I'm going to show you the next week. Then we will work out for and then coal and so on. So now we are going to do all these 10 calculations. So what if outlook equal to sunny? So we have applied a filter on outlook equal to sunny. So in the actual data set, this is our actual data set. In our actual data set, I hope you are able to understand the term filter. You might have used the Excel spreadsheet where you apply some filter on some values and filter only some records. So in this outlook, we are choosing only the sunny, the records which are having the value sunny. So as per the filter, only some 5 records will be eligible for our calculation, because we are going to do the first calculation for outlook equal to sunny. So we are interested only on these 5 records. So outlook equal to sunny. So observe this first calculation very carefully. The other calculations are going to be just the similar way. So I'm going to rush through the other calculations. Only the first calculation I'm going to explain you in detail. So observe this first calculation very clearly. It's actually very easy. Just you only have to understand the procedure. So uh, we are going to calculate the standard deviation for outlook equal to sunny. So we are interested only in these 5 rows of the entire data. So we have filtered outlook equal to sunny, these 5 records. Now for these 5 records, we are going to calculate the standard deviation. The procedure is same. We have these 5 values, take the average of these 5 values, which is 35.2. And based on that, you know the standard deviation formula. So you apply the standard deviation formula for these 5 values, and then you will be getting the standard deviation value as 7.78. So the standard deviation formula is just like this: square root of sum of squared difference between each value and the mean value. So you are going to, for these 5 values, you are going to calculate the squared difference and take the average and take the square root. That will give the standard deviation for the number of golf players for outlook equal to sunny. So we have this value for outlook equal to sunny as 7.78. And then similarly, we are going to repeat the same calculation for outlook equal to overcast. So in this outlook equal to overcast, we are going to do the calculation only for the records that are having outlook equal to overcast. So I think there are around 4 records that are having outlook equal to outlook equal to overcast. So there are 4 records with outlook equal to forecast, overcast. So for these 4 values, we are going to calculate the standard deviation, which is 3.49. And then we are going to repeat the same for outlook equal to rainy. So for outlook equal to rainy, there are 5 records with outlook equal to rainy. So for these 5 values, we are going to calculate the standard deviation. Now we have completed one attribute, that is outlook equal to sunny, rainy, and overcast. Now based on these 3 values, we are going to calculate the weighted standard deviation for this attribute. So this outlook feature had 3 values, that is overcast, rainy, and sunny, and we had calculated the standard deviation of the uh, outlook equal to overcast, rainy, and sunny as 3.49, 10.87, and 7.78. That is based on the previous 3 values, 7, 3, and 10. These we have calculated. Now attribute altogether. So for doing that, we are going to consider, like, altogether there are 14 records in this data. So 4 out of 14 says that standard deviation is 3.39, and 5 out of 14 says that standard deviation is 10.87, and 5 out of 14 the standard deviation. So into 3.49 plus 5 divided by 14 into 10.87 plus 5 divided by 14 into 7.78. So this is going to give the weight. So now we have calculated the weighted standard deviation for standard deviation deviation for the entire data. With all the data, what we have calculated, this deviation in the beginning is 7.66. Overall standard deviation is 9.32, and for this attribute it is 7.66. So the standard deviation reduction that this particular outlook attribute will produce is equal to 9.32, the overall value, minus the 7.66, the standard deviation value for this outlook feature. So 9 minus 7, which is approximately equal to 1.66. So it will be appearing confusing, but once you go through this slide again and again, you'll be able to understand this flow. So I hope up to this point you are clear about the calculation. Is there any doubt? Shall I proceed further? Are you able to follow these calculations? Shall I proceed further? Shall I proceed further? Are you able to follow the calculations? Okay, you can stop me if you have any doubt. So now similarly we have to repeat this for the remaining three features. That is, we have completed for Outlook. Now similarly we have to repeat the same procedure. Now we have completed for Outlook and Wind. So what we have to do is we have to calculate the standard deviation for temporal, and then we have to calculate the weighted standard deviation with all these three values, and then we have to subtract this temperature standard deviation value with the overall standard deviation value. So that will give the standard deviation reduction for the temperature attribute, and the same has to be repeated for humidity and wind. So now repeating the calculation for temperature attribute, temperature equal to hot. So for temperature equal to hot, we are going to deal only with the records where temperature equal to hot. So temperature equal to hot, there are some 4 records with temperature equal to hot. So for these 4 records, what we are going to do is we are going to calculate the standard deviation value. So for these 4 records, we are going to calculate the standard deviation value. So the standard deviation value directly I have written here without showing the calculation as 8.95. And similarly, we repeat the calculation for temperature equal to cool and temperature equal to mild. And then we calculate the weighted standard deviation for this entire temperature based on hot, cool, and mild values based on the number of instances out of 14. So 4 divided by 14 into 8.95 plus 4 divided by 14 into 10.15 and plus 6 divided by 14 into 7.65. That will give the weighted standard deviation for this temperature attribute, and subtracting this from the overall value will give the standard deviation reduction. Similarly, we repeat for humidity attribute. For humidity attribute, we have humidity equal to high. For humidity equal to high, we calculate the standard deviation, and humidity equal to normal, we calculate the standard deviation, and then we calculate the weighted standard deviation for this humidity attribute and subtract it from the uh, entire standard deviation. And then we repeat the same similar calculation for the wind attribute. So for wind equal to strong, we calculate the standard deviation, and for wind equal to weak, we calculate the standard deviation, and then we calculate the weighted standard deviation based on these two values, and then we subtract it from the overall value and we get this. So now altogether, if you observe that we got 4 values, that is the standard deviation reduction for the 4 attributes. Standard deviation reduction for outlook, for temperature, for humidity, and wind. So we have to choose the attribute which is giving the highest standard deviation reduction. So if the standard deviation reduction is too small, when it is very near to the overall standard deviation, it will not give so much of information. So it needs to deviate so much from the overall standard deviation so that it will give more information. That is why we choose the attribute which is giving the highest standard deviation reduction. So out of the 4, Outlook is going to give the highest standard deviation reduction of 1.66. So that is why we place Outlook in the root of the decision tree. Now, whenever we get a new record with some values, first we are going to test against the Outlook value, whether the Outlook equal to sunny or Outlook equal to overcast and Outlook equal to rainy. So based on this Outlook will be the first question that will be asked whenever a new record is tested. What is the Outlook value? Based on that only the further decision will be taken, whether we are going to follow this left branch, right branch, or the middle branch. Now the similar calculation is going to be repeated again with outlook equal to sunny. With outlook equal to sunny, we got some five records here. So for these 5 records, repeat the same procedure. So instead of taking the overall 14 records, now we are going to repeat the same calculation with these 5 attributes, standard deviation. After that, now we have completed with overlook. So all the values in the overlook column are sunny. Now we have 3 attributes here: temperature, humidity, and wind. So we need to decide which of these 3 will sit here. So when outlook equal to sunny, what is the next question to be asked? Whether it is to be based on temperature or based on humidity or based on wind. So that we have to decide whether it is to be temperature, humidity, or wind, which is supposed to be in the next level on the left branch of the outlook. So for that, we are supposed to repeat the entire calculation. So we need to calculate the standard deviation of the entire data, and then we have to calculate the standard deviation of temperature equal to hot to deviation, and then the standard deviation reduction of the temperature attribute. And then we need to repeat the calculation for humidity equal to high, normal, and then the weighted standard deviation, and then the standard deviation reduction for humidity, and then standard deviation for wind equal to weak and strong, and then the weighted standard deviation, and then the standard deviation reduction for this wind attribute. And based on these 3 standard deviation reduction values, just like this, we will choose the attribute which is giving the highest standard deviation reduction as the attribute that is going to sit here. So what is the attribute that is going to sit here? So now we will start with doing the similar calculations here. We'll start with temperature equal to hot. So first we need to calculate the standard deviation of these 5 records. So standard deviation of these 5 records is equal to 7.78. Now we will do for temperature equal to hot, mild, and cool. So for temperature equal to hot, there are 2, and then for temperature equal to cool, there is only 1 record. So standard deviation is 0 because average is 0, and the value minus the average is 0. And then for temperature equal to mild, the standard deviation is 6.5. So based on these 3 values, now we will calculate the weighted standard deviation. So based on these 3 values, we will calculate the weighted standard deviation as 3.6 for this temperature attribute when outlook is sunny. And then we will subtract this 3.6 from 7.78, which is the standard deviation for outlook equal to sunny. So the value is 4.18. Now we will repeat the same procedure for the other 2 attributes, that is the humidity as well as the wind. So for humidity, we have humidity equal to high and we have humidity equal to normal. So when the humidity is high, we have 3 records. So for these 3 values, we will calculate the standard deviation. And then for humidity equal to normal, we calculate the standard deviation for these 2 values. And then we calculate the weighted standard deviation based on these 2 values for humidity feature. And then we subtract it from the overall outlook equal to sunny standard deviation, which gives this standard deviation reduction. So we repeat the same procedure for outlook equal to sunny and wind. For the wind attribute, we have wind equal to strong and we have wind equal to weak. So when we have wind equal to strong, we have 2 records, and when we have wind equal to weak, we have 3 records. So we calculate the standard deviation for wind equal to strong and then for wind equal to weak. Then based on these 2 values, we calculate the weighted standard deviation and subtract from the overall standard deviation, which gives the standard deviation reduction as 0.85. So now we have the standard deviation reduction for these 3 attributes, that is wind, humidity, temperature, humidity, and wind, for outlook equal to sunny, only for this sub branch. So out of these 3, temperature gives the highest value, highest standard deviation reduction. So we choose the temperature as the next decision attribute on the left branch of Outlook. That is, when Outlook equal to sunny, the next question is what is the temperature value, whether it is cool, whether it is hot, or whether it is mild. So whenever we get a new record to find out to predict the outcome, first question what we ask is what is the outlook. If we say the outlook is sunny, then the second question is what is the temperature. So this is now presently determined. So we know that when outlook equal to sunny, the next question is supposed to be based on temperature. Now when outlook equal to sunny and temperature, there are three options, that is cool, hot, and mild. So when outlook equal to sunny, we have 5 records when outlook equal to sunny. So when outlook equal to sunny, we have these 5 records. So out of this, we have decided that temperature is giving the, out of these 3, temperature is giving the highest SD reduction. So we are choosing the temperature as the next decision attribute here. So in this temperature, we have hot, mild, and cool. We have 3 types of values. So that is what we are going to process here now. Are we going to repeat the entire calculation again for these 3 sub-branches? The answer is no. Why are we not going to further sub-branch these values? So we will go for sub-branching only there are 5 rows in this sub-data. We will go for sub-branching. Otherwise, we will not go for sub-branching. We will then temperature. In temperature, we can go for 3 sub-branches. So we will have one data here, one data here, and one data here. You can see that none of the data is having at least 5 records. So we will not further proceed our branching. We can actually do the branching, but it will not be very effective. So we will be doing something called as pruning the tree. So after this, we will not build any further sub branches. We will stop branching process. So that is called as pruning. So we will halt the calculation for this branch up to this. Now we will proceed to the second branch. So what we have done is, so up to now what we have done is, we have uh, identified that outlook will be in the root level, and on the left side we will put a temperature attribute, and after that we will stop the branching. Now what if outlook equal to forecast? When outlook equal to forecast, we have 4 records. So we have decided that there should be at least 5 records to proceed with further branching. So when outlook equal to overcast, you can see that there are only 4 records. Only there are 4 values. So since there are only 4 values, we will not further sub branch this outlook equal to overcast. We will prune here itself. We will not further do any sub branching. So this branch is pruned here itself. Now we come to this branch. What if outlook equal to rainy? When outlook equal to rainy, we have at least 5 values. So here, since there are at least 5 values, we have to calculate the overall standard deviation. Then we have to calculate the standard deviation for temperature equal to mild, cool, and then we have to calculate the standard deviation, that is the weighted standard deviation for temperature, and we have to calculate the standard deviation reduction for temperature, and then we have to calculate the SD for humidity equal to high and normal, and then calculate the weighted SD, and then the SD reduction for humidity, and similarly for wind also we will calculate the SD for weak and strong, and then the weighted SD, and then the SD reduction. So based on that, we will choose which attribute will be suitable to be placed in this point to take the next decision in the right side branch. So the calculation goes on like this. What if the outlook equal to rainy? When the outlook equal to rainy, we have at least 5 records. So that is why we are going to to the continue with the further calculation. When outlook equal to rainy, we have these 5 records for which the standard deviation is 10.87. Then for outlook equal to rainy, for this temperature attribute, we have two values, cool and mild, for which the standard deviation are 14.5 and 7.32 respectively. Based on this, we'll be calculating the weighted standard deviation for temperature, and we'll calculate the standard deviation reduction for temperature. Similarly, we will repeat for the humidity and wind as well, and find out the standard deviation reduction for these two attributes as well. So we have tabulated here the standard deviation reduction for outlook equal to rainy, and temperature, humidity and wind standard deviation reduction we have listed here. So you can observe that wind gives the highest standard deviation reduction. So in the right side of the outlook, where outlook equal to rainy, we will put wind as the decision making parameter. So you can observe that in the this particular figure, you can observe that in this particular figure, that the right side branch of outlook. So the right side branch of outlook, where outlook equal to rainy, we had these 5 values, and finally we have concluded that wind will be the value that is going to sit here as the decision making parameter. Here we have actually pruned, and here we have selected temperature as the decision making parameter, and here we have chosen wind as the decision making parameter. So having made these decisions, so having made the decision that a wind will be sitting on the right side of the outlook branch, where that is when outlook equal to rainy, we have wind as the next parameter to decide. So wind again has two values, weak and strong. So in weak branch we have 3 records, and in strong branch we have 2 records. That is outlook equal to rain and wind equal to weak. These 3 records, and outlook equal to rainy and wind equal to strong, we have these 2 records. So do we have to do any further sub branching? The answer is no, because in both these branches there are less than 5 records, so we will not go for further sub branching. So we will prune the tree here, and we will conclude that this is the overall tree. So when outlook will be the attribute that is going to sit in the root of the tree. When outlook equal to overcast, we had only 4 records, so we terminated further sub branching. When outlook equal to sunny, there were 5 branches, so we further did the calculation and identified that temperature is the suitable attribute. And when outlook equal to rainy, there were at least 5 records, so we did the further calculation and identified that wind is a suitable attribute here, and this forms the decision tree for this given data. Now you can observe that in the leaf nodes, that is in the terminal nodes, you can find some values here. So what are these values? So what are these values? So these values are the average values of the records that are filtered here. So when outlook equal to sunny and temperature equal to cool, when outlook equal to sunny and temperature equal to cool, you come here, you observe this outlook equal to sunny. Okay, outlook equal to sunny, and so we have this outlook equal to sunny, and based on temperature we have 3 branching, one for cool, one for hot, and one for mild. So for the cool branch there is only one value, so we take it directly. Whereas for hot we have 2 values, so we take the average of these two, that is 25 plus 30 by 2. And for temperature equal to mild, we have 2 values, that is 35 and 48. So we take the average of these two values. That is what is written under temperature for cool, hot, and mild. For cool, you can observe that there is only one value. So taking the average also is going to give the same value. And for temperature equal to hot, under outlook equal to sunny and temperature equal to hot, you can see the average of these two values. And under outlook equal to sunny and the temperature equal to mild, you can see the average of these two values. Similarly, when outlook equal to forecast, we did not perform any further calculation because there were only 4 records. So we directly take the average of these 4 records and we directly write it under outlook equal to overcast. So these are all the average values of the records that has been filtered based on the above criteria. So yeah, where outlook equal to sunny and temperature equal to cool, there was only one record with value 38. So directly it has been written here. And for outlook equal to sunny and temperature equal to hot, there were two values with 25 and 30. So the average of 25 and 30 is 27.5, which is written here. Similarly, for mild also, there were two records. The average has been written here. For outlook equal to 4 overcast, there were only 4 records, so we did not do any further sub branching. So directly we have taken the average of those 4 values and written here. And then for outlook equal to rainy and wind equal to weak and strong, so we have 3 on one side and 2 on other side. So we will take the average of these 3 to write under weak and the average of these 2 to write under strong. So that is what we have written under weak and strong, these values. Now this is the entire tree that will be used for prediction. Now whenever we are getting a new record which is not available in our input data. So here we have some 14 records based on which we have done the learning and we have developed this decision tree. So whenever a 15th record which comes out of this combination. So here we have a lot of combinations for outlook, temperature, humidity and wind. Whenever a new pattern arrives, what is going to be the number of golf players? That is what we are going to predict here. So when we get a unknown combination, we will be applying that combination on the tree. So first what question we will be asking is, what is the outlook value? So what is the outlook value? If the outlook is overcast, we will say that probably there could be 46.3 players. If the outlook is sunny, then based on the temperature value, we may say that if it is cool, there could be some 38 players. And if it is hot, there could be some 27 players. And if it is mild, then it can be some 41 players. And if the outlook is rainy, then based on the wind, we will say that if it's weak wind, then some 47.7 players could approximately come for the day. And if the wind is strong, then we could say that some 26.5 players could come on that day. This is how the prediction will happen in the case of the regression tree. Is it clear? Any doubt? So here it's lot of arithmetic calculations, except that this technique is actually very simple. It's only based on the standard deviation. So if you have any doubt, you can ask me. Meanwhile, I will note down your attendance. Shall I call out your registration number? Triple E 18 batch 55 is there? Absent? 19 batch number 3? Absent? And triple 19 batch number 4? 3 and 4 are present, right? 3, 4, 5, 10. 3, 4, 5. 7 is absent, right? Triple 19, triple 19 batch number 7. Arjun is absent. 10, 11, 12, 14, 15. 10, 11, 12, 14, 15. So 13 is absent.